in the previous discussion, we were able to discuss the definition of inverse function, as well as on how to show that the two functions are inverse functions or they are inverse of each other. Now, today we're going to discuss a method of finding the inverse function. So, we have a theorem. This one is very important. If an equation y is equal to f of x can be solved for x as a function of y, that is, x can be written as this one, x is equal to g of y, then f has an inverse, and that inverse is denoted by g of y, which is equal to f inverse of y. So the theorem states that if we are given a function y is equal to f of x, then along the process we can solve x, which is in terms of y. So in this form, x is equal to g of y. Then that function has an inverse, and that inverse is denoted by g of y, which is equal to the f inverse of y. So here is a procedure of finding the inverse of a function f. Number one, write down the equation y is equal to f of x. Okay, that's the number one step. Number two, if possible, solve this equation for x as a function of y. That means that if we already have a function y is equal to f of x, then we are going to manipulate that function until we can solve x in terms of y, if that is possible. Number three, the resulting equation will be x is equal to f inverse of y. Okay, because we assume that we can write x in terms of y, right? That is x is equal to g of y. So that resulting equation x is equal to the f inverse of y, which provides a formula for f inverse with y as the independent variable. So that means the expression x is equal to f inverse of y, so that y is actually the independent variable if you want to have an independent variable, which is y. However, in step 4, if y is acceptable as the independent variable for the inverse function, then you are done. So if if the instruction says that let y be the independent variable, then we are done. But if you want to have x as the independent variable, then you need to interchange x and y in the equation x is equal to f inverse y of y to obtain y is equal to f inverse of x. So that means that if we have an equation x is equal to g of y, and then we want to have x as the independent variable, so all we have to do is that to interchange the x variable with the y variable. Then we have to obtain y is equal to the f inverse of x. Okay. So here are the examples. Find the inverse of the function f of x is equal to 3x minus 2 with x as the independent variable and state the domain of f inverse. Okay, what is the domain of f inverse? Now in this case, what we going to do is to follow the procedure. First step is let y be equal to f of x. Now, since our f of x is 3x minus 2, so we have y is equal to 3x minus 2. Step 2, we solve for x in terms of y. So, we are going to solve x in terms of y. So, we have, this will be transposed to the left side. So, we have negative 3x. Okay. Negative 3x is equal to negative y minus 2. But we can also multiply both sides by a negative. So that's why we have 3x is equal to y plus 2. And then, since we want to solve x in terms of y, so we have to divide this one by 3. So we have x is equal to y plus 2 over 3. Now, this x is equal to y plus 2 over 3. This is actually our f inverse of y is equal to y plus 2 over 3. This is now our f inverse of y because the independent variable here is y. Okay? But we want to have x as the independent variable. So what are we going to do? So since we want to x to be the independent variable, so we reverse x and y to produce the formula. So we interchange y with x and x with y. So this y here becomes f inverse of x, and this y here becomes x plus 2 over 3. So therefore, our um, our f inverse of x is equal to x plus 2. Okay? This is our f inverse. Now, the second one is state the domain of f inverse. Okay, what's the domain of f inverse? In this case, take note that we have the given function, right? Then the domain of the given function is what? The domain of this is R, correct? And the range of that, if we are going to input any real value, so we can also have an output which is any real value, which means that the domain of the given function is R, which is the set of all real numbers, and the range is also set of all real numbers. So in this case, since we know that the domain of the given function is equal to the range of the inverse function, and the range of the given function is equal to the domain of the inverse function. So therefore, the domain of this, okay, since the range of this given function is R, so that range becomes the domain of the inverse function. Therefore, the domain of this inverse function is also R, or is the set of all real numbers. Okay? So we have here important remarks to remember. So we have theorem. A function has an inverse if and only if it is 1 to 1. Okay, this is already a theorem that a function has an inverse if and only if it is 1 to 1, which means a function has an inverse if it is 1 to 1. Now, if it is 1 to 1, okay, then it has an inverse. That's why we are using the if and only if here. Okay? So the second remark, a function f is 1 to 1 if and only if f of x sub 1 is not equal to f of x sub 2 whenever x sub 1 is not equal to x sub 2. Okay? Actually, we can show that a function is 1 to 1, and I have an example in the next slide. So don't worry. So this only means that a function f is 1 to 1 if and only if f of x sub 1, which is the value of f at x sub 1, is not equal to f of x sub 2 whenever x sub 1 is not equal to x sub 2. Okay? So the next remark, geometrically, a function f is 1 to 1 if and only if the graph of y is equal to f of x, okay, is cut at most once by any horizontal line. So in the next video, we will be tackling about the horizontal line test. Okay, that is to show whether a function is 1 to 1 or not. Okay. So for the next slide, or for this slide, we have here an example on showing that a function is 1 to 1. How? So for example, show that the function f of x is equal to 3x plus 4 is 1 to 1. How to show that this function is 1 to 1, even if we do not know the graph of this function? Okay, by just only using the algebraic um, algebraic notation, how can we show that this one is a one-to-one function? So suppose that there are numbers x sub 1 and x sub 2 such that f of x sub 1 is equal to f of x sub 2. Okay, so we assume that there are numbers x sub 1 and x sub 2 such that f of x sub 1 is equal to f of x sub 2. Okay, that's our assumption. Next is, so since this one, f of x sub 1 is equal to f of x sub 2, therefore, by this given function, we are assuming that x sub 1 and x sub 2. So we just following, we're just following this formula here. F of x sub 1, so we have 3x sub 1 plus 4 is equal to 3x sub 2 plus 4. Then we solve for um, what? We solve for x sub 1 and x sub 2, or we combine like terms. So this 4, okay, plus 4, and there is plus 4, so this will be cancelled because this will be transferred to here. So we have 3x sub 1, 4, this is 4, so this will be transposed to this side. So 4 minus 4 is 0. So we only have 3x sub 1 is equal to 3x sub 2. Okay, so by dividing this 3, okay, both sides, we divide it by 3. So we come up with x sub 1 is equal to x sub 2. Okay, so that means that there is only um, distinct element in the domain, okay, and that element corresponds to only one um, element also in the range. That's why x sub 1 is equal to x sub 2, okay, and f of x sub 1 is equal to f of x sub 2. So therefore, f is 1 to 1. Again, you can show that f is 1 to 1 given this algebraic expression by assuming that there are numbers x sub 1 and x sub 2 such that this one is true. Okay? Then by following, by supposing that f of x sub 1 is equal to f of x sub 2, then follow the formula, then until you get x sub 1 must be equal to x sub 2. Therefore, f is a one-to-one function. Okay? So that's it. So here is an exercise. Find the inverse of the function f of x is equal to x raised to 5 minus 3 over 2 with x as the independent variable. So here, all you have to do is just to follow the procedure in order to find the inverse of this given function. So thank you so much. Hope you like this video, and do not forget to share the learning that you got from this video. Thank you once again, and God bless.